Yeah.
All right, so we are the mobile monitor group, and you're just in here, but I'm Brad.
I'm John.
James.
I'm Cooney.
All right, so for the vision for our project, we want a compact and portable network of sensors that can monitor an animal's environment and health. Improved animal safety and comfort is what we're aiming for, as opposed to the larger, more expensive sensors that we saw were being used at the animal shelter at Woodland. We want remote monitoring of enclosure conditions so that animal caretakers can see the data from wherever they need to through the web. Long-term analytics and trends. Basically, we want you to leave this sensor in the field for a long period of time to see long-term trends in changes of CO2 data, noise, and stuff like that. We want caretakers to have insight into potential health hazards quicker and be able to diagnose problems faster. We have off-the-shelf sensors which ensure a low cost as opposed to $700 or N plus CO2 sensors that were being used before. Designed from the ground up to be portable and easy to recharge. We have USB recharging, and the entire sensor block is much smaller than the kind of sensors that were used before. And since there are minimal wires, non-invasive monitoring for animals, which is really important. We don't want to monitor their health while making it worse at the same time. Basic system overview. In terms of alpha, we can track temperature and humidity data over long periods for long-term trends in the animal's environment, and also have a microphone for, in the case of dogs, excessive stress barking, which is a large problem since that's hard to monitor light. With just a caretaker in there, it's difficult to tell when the barking is excessive and when it's just normal, healthy barking. We have battery and power active for several hours on a single charge, and we can recharge very easily with a mini USB connector. All right.
So this is the 3D render. Anuj did this, by the way. And so it's just the P-sock in the middle, the USB charger down there, the microphone jack is here, and up there is the JST connectors. And what we're going to be doing is putting it inside this Poly XML series. And what we want to do is want to cut slots on the sides so we can put on the hydrophobic sealant so we can let air go in for to measure for the cozier to measure the CO2 levels and to block water.
Because these enclosures need to be cleaned.
Yeah. Left?
Yeah.
Double.
Oh.
So here's a look at the Team Charlie mobile animal monitor MATLAB GUI. We're going to be monitoring 4 different conditions: temperature, humidity, CO2 levels, and audio for the dogs barking. So to start it up, we're just going to go to measurement mode. Click on both, and right away our data should be updated. And you can see right there we've got about 24 degrees and about 37% relative humidity. So now we're going to record the audio. So to do that, we hit start stop audio. We have recording of a dog barking here. And now the chart should update with the data of the dog barking. There you go. And then same thing with the CO2. Just hit start stop. It's going to collect about 200 different data points. And then plot them in the top right corner of our GUI. It takes a little bit of time for it to get enough points in the buffer for it to update on the chart. And there it is. So you can see we have about 1,200 for our levels and a little bit over time already, so we'll end it there.
Second video is not as important, unless you want to see it. It's our basic setup, but it's not on the alpha board. So
just go
okay. Our
Well, the digital connection is pretty simple. So it's just a humidity sensor which communicates via I2C and NFC speed. That's literally it for digital. And yeah, we're planning on putting the cozier on later, but that wasn't part of the alpha. So yeah.
this part. The sound monitoring, we have a basic microphone. We went with the Olympus ME52, a sound isolation microphone, unidirectional, usually used for speaking into, but we can also make it work for our purposes. Through an audio jack here, we found out through testing that the microphone itself is not preamplified and had around 50 millivolts native voltages coming out of it. So we have a basic differential amplifier here that will give us 10 volts of gain, 10 gain basically, and we, with interchangeable resistors, can change that very easily in our tests. These two components here are actually internal to the PSOC. We use the PSOC native op amps for this to remove any possibilities, like problems that could have come from having op amps put on the board. And all of that amplified output goes into the SAR ADC. From there, UART, and we can do whatever we want with it.
I'll take the power team. You know more better than I do.
Okay. This is our power system. So this is the power charger, which is connected to a 3.7 LiPo battery, and we're using a 3.3 voltage regulator. It's not on the next slide, but basically all our sensors and the PSOC port runs on 3.3 volts. So that's convenient for us, I guess. And we have a USB connector for charging over there, which can be used for like standard cell phone chargers as well. And this is a voltage regulator, like I said earlier, very standard. You get 3.3 volts out because it's a fixed voltage.
Okay, so here's a look at our audio system. Originally, we thought this thing wouldn't need an external power supply, and it doesn't, but it's an electric condenser, which means that it's going to require a pull-up resistor for the signal to come out. But the benefits of that is there's negligible current draw when it's just on standby. And so we measured during data transmission, we got 5 milliamps of current. This is the circuit that we used in our test setup, and it'll be implemented on the beta board. Here's the specs for our temperature humidity sensor. It's pretty straightforward. This is the one that we used last quarter as well. 3.3 operating voltage because we try to keep everything standard across the board, and it's relatively low power. Okay, so here's all the good stuff we're going to put on our beta version. We're switching to PSOC 5. It's going to be nice for our audio to have adjustable gain so we can get it right within the range of the ADC. We also want to be doing some signal processing, so we're looking to upgrade to PSOC 5 so we can do the frequency shift keying a little bit easier. We're going to be adding the CO2 sensor. We already have it in our test setup, but it's not on the board yet. And we're also going to be adding an ambient light sensor to monitor the light conditions inside of the enclosures. Additionally, you might not have noticed on our video, but the problem that we're having with the op amps on the PSOC is that we're getting the negative voltages cut out. Sine waves are sinusoidal, so we're only getting the top half. So we've designed this level shifting circuit that'll boost everything up, so it's all within the range of 0 to 3.3 volts. And we're also going to be switching to the new regulator that has the low Q current, so we'll get some better performance for our power.
Okay, awesome. I'll take one question since somebody has.
Yeah, I have two questions actually. What were the two acronyms for the PSOC 5 on the beta? The FSK.
Oh, okay. So PGA is programmable gain amplifier.
Okay.
So right now we're controlling the gain on the audio, on the preamp, just with pulling resistors in and out and getting better gain. With the PGA, we can go from 0 to 4 dB and just the firmware.
Okay.
We'll do it there. And FSK is frequency shift keying, so that's just for communications. So depending on how we want to process the data, we can. It's just a way of transmitting the data from one place to the other.
Okay. And then my second question was how, like, if you want to send an alert, like for excessive barking, how are you going to detect excessive barking?
So that's not on our current system yet, but we're trying to do it with the threshold level. So if it's with our state machine as it has it right now, we're just going to collect maybe 10 seconds of data every minute or every 10 minutes or something. But if there's a lot of barking,
Like average it over the 10 seconds or something? Or
But
just like
in that case, but then if there's excessive barking, we're going to try that threshold. Like you said, if it spikes up, it'll jump into a different state, but starts recording right away.
Okay.
I'm kicking everyone out. I've emerged now, so get out of here.
Nice.